Hi everyone, we're continuing with using fundamental trig identities to simplify trig expressions. We're now going to add and subtract fractions, namely rational expressions in trig functions of x. All right, let's simplify this. 1 over secant of x, it's good to put parens. 1 over secant of x, that plus 1, minus 1 over secant of x, that minus 1. Now, in my notes here, I don't do a substitution, but I think a substitution might be helpful. So let's go ahead and let u be secant of x. Let's let u be secant of x. And then this here is of the form 1 over u plus 1 minus 1 over u minus 1. And let's proceed from there. So now we're looking at the algebra. We're leaving the trig on the side for now. We're focusing on the algebra. Okay, first of all, we'd like to get a common denominator, the least common denominator, the LCD. These two bottoms are relatively prime, so we're going to take their product as the LCD. The quantity u plus 1 times the quantity u minus 1. Just like if we had 1/2 minus 1/3, then we take 2 times 3, or 6, as our common denominator. All right, so we want to build up these fractions so that the new bottom looks like the LCD. And how do we do that? All right, so for the first fraction here, who's missing? Who's missing from this first bottom to get the LCD? I need a u minus 1. He's missing. So I need to multiply the bottom by u minus 1. That means I also have to multiply the top by u minus 1. That ensures that I'm multiplying by 1. Likewise, over here, who's missing down here, the u plus 1. So I multiply this fraction by u plus 1 over itself. That is, I multiply by 1. And then I'm going to end up with a common denominator, which is the product of u plus 1 and u minus 1. It's the same product over here, just in a different order. But what is the quantity u plus 1 times the quantity u minus 1? It's going to be u squared minus 1, a basic algebra rule. U plus 1 times u minus 1, that gets us u squared minus 1. On the tops, we have u minus 1 minus, don't forget to put the grouping symbols, minus the quantity u plus 1. Now over here, I technically have the right to not put parentheses because the fraction bar implicitly groups the top and the bottom. But the one good thing about putting the parentheses in, aside from it being visually appealing, is that it reminds us that when we subtract this numerator, we need grouping symbols, the quantity u plus 1. So let's work out the top, simplify. We get u minus 1 minus u minus 1. That's a minus over here. See, if students make a mistake and they put a plus 1, they end up with a 0 on top and they get very confused. So what happens when we simplify the top? Well, the u and the opposite of u do knock each other out. We get 0 from u and the opposite of u. Negative 1 minus 1 is not 0, it's negative 2. So we get negative 2 over u squared minus 1. And this basically finishes the key algebra phase of this problem. You might be tempted to factor the bottom, but then you'd be kind of going backwards. And actually, we like having u squared there because we like having squares of trig functions. And remember why. Let's go back from u to secant of x. U was secant of x. Remember, in my notes, I didn't do a substitution. I just used secant of x, which is fine. Build up the fractions, get a common denominator, group over here. These cancel out. So we have negative 2 over, again, u squared, which is now secant squared of x, minus 1. But we're not done yet. We have the square of a trig function. We have a negative 1. We might be smelling Mr. Pythagoras, a Pythagorean identity. And in fact, a Pythagorean identity will help us. It turns out that if this were a plus 1, an identity wouldn't be so helpful. But the fact that secant squared of x minus 1, it does turn out that an identity will help us simplify. Now, who's the partner here? What was the squared trig function that went with these guys, secant squared of x and plus or minus 1? It was tangent squared of x. But is this equivalent to tangent squared of x? Do we have the right sign here, for example? Well, let's see. What was that Pythagorean identity that involved these trig functions? It was, remember, we're trying to replace this over here, secant squared of x minus 1 is that tangent squared of x. Let's see. The Pythagorean identity said that 1 plus tangent squared of x, or vice versa, equals secant squared of x. So the goal is, how do we get this bottom, secant squared of x minus 1? I can get that by subtracting 1 from both sides. Secant squared of x minus 1, which was the bottom here, is equivalent to tangent squared of x. In fact, they even have the same domain restrictions when cosine of x is 0. So we can replace secant squared of x minus 1 by tangent squared of x. So we have now negative 2 over tangent squared of x. But we're not quite done, because we want to try to avoid fractions here. What is the reciprocal of tangent squared of x? What does this basically hop up as a factor? The answer ends up being negative 2, and then this hops up as the reciprocal, cotangent squared of x. If you don't believe me, remember, you can write this as negative 2, or negative 2 over 1 if you wish, times 1 over tangent squared of x, kind of peeling this apart. Again, the reciprocal of tangent squared of x is cotangent squared of x. So that big, ugly expression way up here ends up simplifying to negative 2 cotangent squared of x. Much, much simpler. That's as compact as we can get it. We can't do much else to make it better. Next up, trig substitutions.